Kepler here. I'm here to talk to you about our next topic in math, which is topic 12, volume of solids. So we're going to be talking about volume here, which is something new that you probably haven't learned about before. So before we get started, we're just going to do a quick definition of volume and give an example so you can be picturing it in your mind when you see some of these problems. So the definition of volume is that volume is the amount of space inside of a solid object. The amount of space, and you want to write this in your notes too, inside of a solid object. Okay, and what that means, a solid object is not an object that is rock solid, like a rock. A solid object is actually just a three-dimensional figure. That's the math term we use for it, is a solid object. So if you're thinking of an example of volume, volume is how much space is inside of one of those three-dimensional figures. So if you think about a water bottle, for example, is a cylinder. That's a three-dimensional figure. And if you think about a water bottle, the amount of space inside is how much water would fill up your water bottle. So an example would be how much water can fill up your water bottle. That's what we're talking about when we think about volume. So in 5th grade, we are going to be talking about the volume of rectangular prisms, and rectangular prisms are objects that look like a box. So I'm going to give you an example here. This is an example of a rectangular prism, and this one has 3 dimensions to it that you can see. When we look at those 3 dimensions, that's what's going to help us find the volume of the figure. And we look at this formula, volume equals length times width times height. And that's the formula we're going to use for the beginning stages of finding volume. Now, I made a cursive L there. The reason for that is you can easily mix up an L and a 1, lowercase l and a 1 when you're doing math. So you want to make sure that you use a scripty or cursive L when you do a problem like this. So the basic way to find volume is really just to plug in your 3 dimensions into length, width, and height. You always want to write your formula down first, and then you're going to plug those numbers in. So my length is right here, 4 inches. That's usually going across the bottom. The number that goes back is what we consider our width. So we're going to do times 6 inches. And then our height is how tall our figure is, times 3 inches. Now what this is really showing us is if I were to divide this into little boxes, whoops, let's get rid of that one. If I would divide this into little boxes, this is almost like 3 layers, because it's 3 inches tall, 3 layers that are each 1 inch tall. And what you're doing first, if you remember finding area when you were in 4th grade or 3rd grade, your area is your length times your width. So you're really finding the area of one layer and then multiplying that by how many layers you have. So finding the area of my bottom layer would be 4 times 6, and then I'm multiplying that by 3 because I have 3 layers tall. Okay, so 4 times 6 times 3, if you do 4 times 6, you get 24, and then times 3 is going to be 72 inches. And what we do when we find volume is we actually use a little superscript, we call it, or an exponent of 3. And what that means is that there are 3 dimensions in this figure, which we just looked at, length, width, and height. And that's going to be important to remember later, that volume always has a cubed symbol. We say cubed when we write that 3 because there are 3 dimensions. So we would read this as 72 inches cubed. Okay, here's another problem. I want you to pause the video when I tell you to and try to find the volume of this figure on your own. Go ahead and pause the video now. Okay, hopefully you have unpaused the video and you have some work that looks like this. Volume equals length times width times height. You wrote your formula out. You did 1 centimeter times 10 centimeters times 8 centimeters. And you should have gotten 80 centimeters cubed. Hopefully you remembered to put that label on. That's going to be the most important part of solving a problem like this so that we know what, whether it's a three-dimensional figure or whether you're finding area or something else. Okay, so the other formula that you'll sometimes see for volume is that volume equals base times height. And when we say base, this capital B really means the area of the base, which we just talked about a couple minutes ago. If you multiply your length and your width, you're going to find the area of the first layer, and then the height is how many layers you have on top of that. So sometimes they give you those first two layers already, or those first two dimensions already multiplied together, and they call it the area of the base. And so all you have to do is plug in two numbers this time. So volume equals 15 times 3, area of your base, times your height. And if you do 15 times 3, you get 45 inches cubed. Remember, volume is always cubed. And even though we only multiplied two numbers here, the area of the base is really the other two dimensions that are already multiplied together. So we have two dimensions and then one additional dimension, which makes 3. Okay, you are going to try this one with me, but I want you to write this down in your notebook as we go through it. One of the ways that you will also sometimes see problems for volume is where they will give you the volume and then they'll give you one of the dimensions or two of the dimensions, and you have to find the last piece. So what this should also say here is that base equals question mark, because they want you to know, they want you to find the base here, the area of the base. So if I use that formula I just gave you, volume equals base times height, if I plug my numbers in, I get 128 centimeters cubed equals something, because we don't know the base, times 4 centimeters. Now, if you think back to the beginnings of math, you know that in order to find this number here, we have to think what number times 4 equals 128. And to solve that, you have to do a division problem, which is kind of weird because this looks like a multiplication problem. But you have to do the opposite operation so that you can find that number. So you're going to do 128 divided by 4. You can do that on your calculator if you want to, or you could do it by hand. You should get the answer of 32. And so if you do that, we'll get the answer. Oops, I erased some of that too there. You'll get the answer of 32 centimeters, and you actually have to put squared here because remember the area of the base is two of those dimensions. All right, so finally, I have two problems that I want you to try on your own. These are challenge problems, so you're going to have to take some time to think about them and think about what volume is. If you need to go back and look at any of the formulas or see how we solved a problem previously, you can go back and rewind the video. And for number 1, you're trying to find the height of this figure. You know the length and the width. You're trying to find the height. And you also know the volume. And for number 2, you know the volume and the height, but you don't know the base. This is very similar to the very last problem we did. So I would go back and watch that if you're not sure what to do. Do your best on these two problems. Bring them with you to class. We'll go over it in class. And then this will help us build as we do some more difficult problems with volume later on. Thanks for watching.